Hello, everyone, and welcome to this webinar on soil organic matter with cover crops. I'm Stetcyn Maldonado, and I'm here with Tom Johnson.
Hi.
And here's the roadmap for what we're going to be talking about today. I'm going to cover the organic matter portion of this talk, and Tom is going to be going over the cover crops and how those affect organic matter in the soil. To start off, let's discuss what organic matter is. So organic matter is well-decomposed, formerly living material within the soil profile. It's one of the defining aspects of topsoil. So Tom was describing this, and it's a good way to put it, is that a microbe will be breaking down, say, your cover crop, they're pooping that all out, and then something else is coming and they're eating that microbe poop, maybe the dead microbes themselves, and they're pooping that out, and then something else is eating that poo, and eventually it gets broken down to the point where it's very, very difficult to break down further, and that is the stable organic matter, stuff that's going to be in your soil for a number of years. Primarily, it's composed of carbon, so much of that physical mass is going to be made out of carbon. This is why it's sometimes called organic carbon or soil carbon. That's what they're discussing, is they're discussing organic matter. And it contains other elements as well, such as nitrogen and phosphorus. Whatever that biomass was composed of previously, a lot of those elements are still there. And though it's not well understood, a large portion of organic matter can come from decomposed microorganisms. So excluding the plant biomass, the animal biomass, there's also the physical mass of the microorganisms and their products. So for example, there's some fungi. When they're growing through the soil, they'll exude material that coats that soil surface, or I guess those particle surfaces, and it kind of glues them together. That also counts as organic matter. And as far as the microbes themselves, that dead biomass is called the necromass. I love that term.
Word for the day, yes.
The word for the day, necromass.
Necromass.
So for soil effects, why do we even want organic matter in the soil in the first place? So organic matter improves the soil by affecting multiple aspects. So you get better soil texture. So you're getting more carbon into there. It's not just the sand, silt, and clay, and then the air and water portion. You're getting looser, more porous soils, so the soils are able to breathe better, which is good for maintaining plant health and for building and growing your microbial communities. It increases the water holding capacity, and I'll talk about that later, but it helps hold onto water. There's a greater cation exchange capacity, so you're keeping more nutrients in the soil as opposed to losing them through erosion or through leaching. There's improved microbial living conditions, and you get better soil tilth. So the soil feels nicer. A lot of people who have dug through soil that has good organic matter, it's soft, it's pleasant, and it's kind of like you bring it up and you smell it and it smells nice. Compared to something like in this picture, I bet you that you can just scratch through that slightly powdery surface and then you're going to hit a really hard bit of earth underneath it, and it's not going to be as pleasant. Do you know what that soil was feeling like, Tom?
Pardon?
This picture. I think did you send me this picture or no?
Yeah, I sent you that picture. Yeah, we had 3 inches of fluff and hard pan underneath.
Yeah. Not probably, yeah, it sucked.
I mean, it was decent organic matter, but it could have been a lot better. Basically, it had been over farmed for years and years.
So there's the microbial effects on organic matter. So organic matter can act both as a food source and as a habitat. So kind of imagine it as a forest ecosystem on the microscopic scale. The trees of that forest would be the organic matter, while the animals that are running through there, the birds, the deer, those would be the microbes. So soils which have higher percentages of organic matter typically have healthier microbial communities. So a forest that has more trees typically has more critters or healthier critters. Microbes help support plants with nutrient uptake and nitrogen fixation. So nutrient uptake, there are microbes that'll form a symbiotic relationship with your plants. There's rhizobia, which are your nitrogen fixers. There's also arbuscular mycorrhizae, which kind of act as a pseudo plant root. So the plant will feed that fungi, and the fungi will grow and they'll absorb some nutrients that the plant might not have been able to get access to, and they'll trade that way. And a healthy, diverse microbial population can suppress plant pathogenic organisms. So I was trying to describe this to my mom earlier. I don't want to throw out the word diversity just because I can, but there's always a place for something, and the more places that are taken up by beneficial microorganisms, the fewer spaces are available for the pathogenic ones. And the more critters you have going on in that area, the more uh, the less space there is for disease. And there's also critters that will be out there that will attack those disease-causing organisms as well. And then microbes improve soil aggregation. So like I was mentioning earlier, they can help glue those soil particles together, which makes them harder to erode. But also, if you imagine the water coming through that soil profile, instead of the particles kind of like floating around and getting squished or whatever, they're more like a sponge, so the water can move, but it's not going to disturb the soil. And nutrient interactions. So nutrients can adhere to organic matter. It keeps them in the soil for longer and reduces leaching. So organic matter is negatively charged, and that's important because a lot of plant nutrients, not all of them, but a number of them are positively charged. So as they're going through that soil profile, if they come in contact with soil organic matter, they're going to adhere. I'm trying to remember.
They're going to bind to the sites is what's
Yeah,
going on.
they're gonna stick, but it's gonna be like static electricity. So like if I took some paper and rubbed it on me and the paper sticks, that's the kind of bond that
Yeah,
they're gonna have.
it's not a strong bond, but it's there.
Mhm. Yeah. And as organic matter decomposes, it also releases plant nutrients. So you can consider it to be a very long-term, slow-release fertilizer. Every year, no matter what you do, organic matter is going to break down and it'll release some nutrients to the soil. A professor of mine described it to me when he was working with farmers in Brazil and they were clear cutting portions of the rainforest. They would say the first year is free. And that's just because you can plant anything you wanted. You didn't have to fertilize it or whatever, just because there's so much, there's all the nutrients and everything in the organic matter that's going to keep your farm going for that year. And that's because as it was breaking down, you were getting those plant nutrients.
The same thing occurred basically as they plowed the tall grass prairie in the Midwest.
Yeah.
They called it the sod crop, and usually it lasted about a year and a half, 1 to 2 crops, and then basically that advantage was now gone.
Yeah. For water holding capacity, so for every 1% of organic matter, you can hold about an additional 20,000 gallons. And I think that's per acre foot of soil, if I recall.
Yeah.
And the way that organic matter holds onto the water is it creates microscopic bridges, which the water can cling to. So it's very much like a sponge. The material of the sponge isn't really what's holding the water, it's those holes, and that makes the capillary action for that water to stay inside of your sponge. And then when soil's dry, those pores between the particles shrink. So like with a clay soil, as it gets dry, it'll start to compress microscopically. And that creates less space in those pores, which increases water loss. So it's kind of just like slowly squeezing that out. Organic matter kind of acts like a scaffolding, and it prevents or it reduces that shrinkage, which slows water loss. So it's kind of like imagining if you had a vase, and as that vase got hot, it started to shrink. You're going to be able to hold less and less and less water. So you're going to be losing more water out of a vase that isn't shrinking. And build up and breakdown. So organic matter is constantly being built up and broken down in the soil ecosystem. So microbes will break down organic matter. This process is largely controlled by the amount of oxygen in the profile. So when you go and you till that soil, sometimes farmers will notice a spike in plant nutrients, and that's because that organic matter got broken down really quickly because of that oxygen. Um, so life, us microbes, are a lot like fire. Everybody knows that fire needs oxygen, especially the more oxygen you have, the bigger the fire. So we need oxygen to break down food sources, same do as mini microbes. So when the microbes are consuming that organic matter, the more oxygen they have, the faster they're able to eat that. Microbes can also create organic matter through decomposing plant or animal matter, exuding compounds into the soil, and through their own biomass, so the necromass that we mentioned earlier. And organic matter builds up when creation exceeds breakdown. So you're always going to have breakdown. You're not always going to have creation. It depends on what kind of feedstock the system is getting. So as we go on further, we're going to be focusing on how do you increase the creation of soil organic matter. You can affect breakdown by not tilling your soil and whatnot. And the climate. So why are people interested in getting organic matter into the soil? Why are people talking about carbon credits? Why do they want carbon in our dirt? So atmospheric carbon retains heat from solar radiation. So it's kind of like a greenhouse. That's why it's called the greenhouse effect. As solar radiation and heat comes from our sun, it ends up hitting our Earth. It doesn't go back out into space. Um, Carbon, which is stored in plant matter and in the soil, is not in the atmosphere. And this is why people are so interested in soil organic matter, is they're wanting to remove that carbon from the atmosphere and put it into the soil somewhere where it's out of the way and where it's going to stay. So here's the portion where I'm going to hand it over to Tom, and he's going to talk about how cover crops affect soil organic matter.
So first and foremost, cover crop is going to act as soil protection, shield against the climate of the soil. So they create a barrier between the soil and the elements. So wind and rain erosion remove quite a bit of topsoil every year, whether we notice it or not, basically. So keeping a cover crop out there protects that through controlling how fast that soil particles can move, that type of stuff. And we're going to make that bulk organic matter basically happening out there. So part of how we're doing that is those plants act as little solar panels, sucking up light energy, combining it with carbon dioxide out of the atmosphere and turning it into a stable form of carbon. So another thing that happens basically is if we can protect that soil surface, the solar rays interact with soil organic matter that it can reach, and it breaks it down faster because of you're adding heat to the system, you're adding energy to break those chemical bonds, and thus you're breaking down your organic matter faster if there's nothing laying on that soil surface. So that's all these years that we've done clean cultivation is part of why we've probably broken down quite a bit of the organic matter in our top 6-inch layer of soil. And then, of course, a cover crop basically is going to make organic biomass. So the organic biomass is the feedstock for the microbes to make it into some more stable forms of organic matter or carbon, soil carbon. So cover cropping is a way that we can do that. We're adding more. We're back to that. If we can make more than we're using up or we're burning off every year, we're going to start building it up type of thing. So cover crop's a way to cultivate a extra plant biomass above and below the soil surface. The terminated cover crops decompose. In other words, we're going to cut the top off and let it either turn it into the soil or we're going to let it lay on top of the soil and it decomposes. That's going to be a slow conversion to soil carbon by microbial activity for the most part. Living plants, like we said, have produced a root exudate, which adds carbon to the soil through feeding that whole system and making that whole thing work, and it's supporting those microorganisms that drive this. So it's just basically a living plant's kind of a bridge between taking carbon out of the atmosphere and putting it into the or leaving it in the soil. So we often talk about organic matter increasing and cover cropping and things like that. And a lot of times the information we're getting is from maybe not where we're at, basically. So we want to put this in here. So outside of California, organic matter is probably easier to build up in soils that freeze. And this is because when it's frozen or cold or snow on the ground, there's limited microbial activity happening at that time. So we slow down how fast whatever's there is going to be digested or broken down, turned into carbon. Other factors on the flip side of that basically is the weather, temperature, rainfall. Adding water to the system makes the plants grow. Plants grow in the summertime, like I said, outside of California. And basically they grow and produce fixed carbon out of the atmosphere into the plant tissue, and the plant tissue then turns it into feedstock for the microbial activity, which will make it into a form that doesn't leave the soil as easily. So with that in mind, we're inside California. Face it, guys, we live in a desert. It rains a little bit in the wintertime and it's long and hot and sunny in the summertime type of thing. So that climate limits our plant growth in the first place, which in turn has probably limited our soil biology. So areas that are commonly farmed in our state do not experience ground freezing either. So we are growing, we have a cool season where we can grow extra biomass and put it on there, but we have a year-round breakdown cycle. Those microbes don't slow down all that much in the wintertime like they do when the ground's frozen. So they're keep going basically on that type of thing. So organic matter buildup with a cover crop in California, you can still do it. It's going to have to be multi-year, and there's probably going to be some other inputs involved in that if we want to make sure we're leaving carbon behind in the soil after everybody's done chomping on it. And some of those additional inputs used in combination with a cover crop would include compost, which is a fairly stable carbon source because basically it's broken down materials to an intermediate stage between green grass and soil stable carbon. Biochar, which is even more broken down, more fixed, but on the other hand, it's putting carbon in there. And the biology not only produces carbon, exudes it, fixes it, and what have you, but it has to have carbon to drive. It has to have some carbon to work with. So if there's low carbon already, it's going to have a hard time finding more. Adding biochar is probably going to accelerate that to some extent. Grazing, between what the livestock's leaving behind after they're grazing the thing off, they're also doing their foot actions, pressing that green matter against the soil probably better than we can with our normal cover crop management tools. And it's allowing that green matter to be exposed to soil biology, which is grabbing hold of some of it and pulling it down into the soil, which is going to accelerate how fast or how well that area is going to be able to fix some soil organic matter. Applying manure has been a long time practice in agriculture, not only for the fertility, but also we're putting some carbon back out there to jumpstart everything. Now we put a little bit of extra fertility, not only nitrogen, but phosphorus, potassium, some of the other micronutrients are involved in that are passed through the livestock. And in that manure, they go out there. That and compost, I always kind of looked at it as there's kind of a biological inoculant that you're putting onto the soil, as well as providing something that's a little easier for them to digest type of thing. And one of the biggest deals that we can probably do, and it's difficult to do in quite a bit of the cropping systems that we do in California, is no tillage or reduced tillage. Because every time you would till the soil, you're going to expose that soil profile to more oxygen. More oxygen is going to drive a faster reaction of the soil biology, converting carbon to a different form of carbon, to a different form of carbon, to a different form of carbon, and somewhere in between, some of that carbon is actually going to turn back into CO2 and potentially be released or become such that the biology can't use it. So where we see in the Midwest a lot of ability to maintain their organic matter or even move it up a little bit is under this no-till, strip-till situation. Again, different climate. They're basically they're kind of doing an active digestion of carbon in the soil for about half the year. Well, out here it's 9, 10, 12, 11 months of the year that's actively going on. So it's going to be a tough do on that. But basically, if we can no-till, which we already do in quite a few of our perennial crops, is going to basically kind of help that. I want to thank our donors. The Seeds for Bees is entirely funded by donations from individuals and corporations. Thus, it makes it free from the shackles of other programs. We can utilize Seeds for Bees with state or federal grant programs if you're doing cover cropping or other practices along that line. We're grateful to the people who make our program possible. Many of them have been with us since it started over 10 years ago now. If you're in a position to donate, or you know someone that wants to donate, the QR code on this slide basically will take you to the landing page for that to make a donation to the Seeds for Bees program so that we can continue to supply seed for cover cropping, soil improvement, pollinator habitat, and all the other things that Seeds for Bees has managed to do in the last 10 years. Thank you.
Yes, thank you for attending. Have a good rest of your day.